So here is another integral for you to attempt, and what I'm going to do is show you how to do it in 3 different ways on the next slide. So I'd encourage you to have a look at it now with pencil and paper, pause the video, come back after you've given it a good shot, and we will see and discuss the details. Okay, welcome back. Let's look at it on the next slide. So on this slide, what I want to do is to calculate the integral in 3 different ways, and I've started all of them off here. And let's look at on the first line here. What I'm thinking is that the derivative of the cosine of theta is minus sine of theta. So therefore, I'm hoping that I can work out what this is by inspection. So my guess is if I write this as cosine squared of theta, then if I differentiate that, I will get the original integrand. And I've left a space here to put in whatever numbers or minus signs may be needed to make this correct. So to do this, I'm going to go down to the bottom and just write this out a little bit more explicitly. So cos squared theta means the cosine of theta all squared. That's what the notation means. So therefore, using the chain rule, the derivative of the cosine of theta all squared is going to be, well, the function on the outside is that we are squaring the contents of the brackets, and the contents of the brackets is a function of theta, it's the cosine of theta. So this is a function of a function. So when we differentiate it, what we do is we bring the 2 in front, we reduce the power of 2 to 1, so instead of having cos squared theta, we have cosine to the 1 of theta, and that's just cosine of theta. And then we multiply, this is the chain rule, by the derivative of what was in the brackets, and that's the cosine of theta. So we brought this in front, reduced it to 1, and just written it as the cosine of theta, and then we multiply by the derivative of what's in these brackets. So what we obtain, bearing in mind that the derivative of the cosine of theta is minus sine theta, is we're going to get minus 2 cos theta sine theta. And that is, so we're differentiating this, and we've got minus 2 times the original integrand, sine theta cos theta, just written in the opposite order here. So to get the minus 2 out of the way, what we need to do is put a minus sign in front to mop up this minus sign, and we also need to put in a factor of a half to cancel with the 2. And in a very similar way, and I'll leave this for you to work out, what we need on the next line is to put in a factor of plus a half. Okay, the third version of doing this integral, so we've got sine theta cos theta integrated with respect to theta, is, well, we might recognize that sine theta times cos theta is a half sine 2 theta. So what I'm recalling there is the double angle formula that sine of 2 theta is 2 sine theta cos theta. So what we have to do is we just rewrite this, put a factor of a half in to mop up this 2, and now take the half outside of the integral to make it look a little bit less intimidating. And now what we have to do is to integrate sine of 2 theta, and that's going to be more or less the cosine of 2 theta. Again, we don't change the argument. So what I tend to do is leave a space, write the function down, and then get the numbers and any needed minus signs right, just by thinking, if I differentiate this, what would I need to have here to obtain this, not forgetting the half. So if I differentiate the cosine of 2 theta, differentiate cosine, you get minus sine. So there's going to be a minus sign, and I don't want that. So I'll just put in a minus sign to mop it up. And then I'll have sine of 2 theta, not changing the argument. That's good, we want a sine of 2 theta. And then from the chain rule, we're going to multiply by the derivative of the argument, that's the derivative of 2 theta. So we would get a factor of 2. So what we would get would be minus 2 times sine of 2 theta. And we want plus a half, so as I've said, the minus sign is clear, but also we want to have a factor of a quarter. So let's think about that. If you differentiate this, you get minus sine of 2 theta, minus minus is plus, multiplied by the derivative of 2 theta, that's a 2. 2 over 4 is a half. So this is correct. So after you've worked out something like this, just go through it in your head again, think, yes, this is working, or it's not working and I've got to fix it. So now, we've got 3 different results for this indefinite integral. And this result looks negative because it's a square multiplied by minus a half. This result looks positive, it's a square times plus a half. And the sign of the cosine can vary, so this could be negative or positive. So what's going on? Well, the answer is that each of these indefinite integrals should have written into it an integration constant. And here I've written them out. And on the next slide, I'm going to talk about how we see that these 3 expressions are actually equivalent to each other. So what I would finally like to talk about is the equivalence of these 3 different results for the same integral. And the key result, I think, is to start off using cos squared theta plus sine squared theta is 1. Because from that result, we see that, for example, cos squared theta is 1 minus sine squared theta. So our result at the top here, minus a half cos squared theta plus c1, can be rewritten as minus a half, and then it's cos squared theta is 1 minus sine squared theta plus c1. And if we just expand the brackets and tidy things up, you can see that we're going to get minus a half, I'll go back to the pen, minus a half plus a half sine squared theta plus c1. So that's a half sine squared theta plus c1 minus a half. And that is what is here written as c2. So we can see that these 2 statements are equivalent once you realise that an indefinite integral is only defined up to an unknown integration constant. And similarly here, for the double angle formula, well, remember the double angle formula is cos of cosine cos 2 theta is cos squared theta minus sine squared theta, and then using this result, that means we can rewrite cos squared theta minus sine squared theta as 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. And so in an equivalent way, which I will leave for you to explore, we can rewrite this either in this way, using this relationship, or we could rewrite this in this way, using this relationship. So all 3 results are indeed equivalent, and I hope you've enjoyed working through this video, and I hope you've seen the importance of realizing that an indefinite integral is only defined up to an unknown additive integration constant.